and welcome. We're going to learn about a very simple mathematical tool today and how we can apply that tool to a broad range of topics in chemistry and in astronomy. The tool is dimensional analysis. Now, I know it sounds complicated, but many of you guys have probably used it before, maybe just not in a scientific application. Let's take a look at the word itself. So, dimensional analysis. It's a very simple mathematical tool. When we say a dimension in science, we mean a unit like length, weight, mass. You've heard of this term before when we talk about dimensions in space. We have 4 dimensions. We have length, we have width, we have height, and then the 4th spatial dimension is time. When we say analysis, we're just using simple math to manipulate the unit from one we don't want to work with to one we do want to work with. And the math we'll be using at the end of the day is multiplication and division. It might look a little intimidating, but I promise you it'll be very simple. The tool of dimensional analysis has 2 parts. The first, an equality statement. Now, an example of a simple equality statement would be 12 things equals 1 dozen. Okay? So we know that if I have 12 pencils, I have 1 dozen pencils. That's intuitive to us. You know of a variety of other equality statements, so 12 inches equals 1 foot, and so on. You've heard them before. Some will be a little less familiar to you, but the process is the same. Once we have 2 units related by an equivalency, a true statement, if someone said, do you want 12 pencils or do you want a dozen pencils? It doesn't matter, those are equivalent things. We can make a conversion factor with this. A conversion factor takes our equality statement and turns it into a simple fraction. So we could say 12 things is equivalent to 1 dozen, or we could say 1 dozen is equivalent to 12 things. Now you might be saying, Hef, wait a minute. 12 over 1 and 1 over 12 are not the same number. And you're right. If we were dealing with simple numbers and not the dimension, these would be different. But because we're dealing with dimensionality, each one of these fractions is actually equal to, if you guessed it, 1. So we can take our conversion factors and use that to manipulate our units and thus dimensional analysis. Now, in the next video, I'm going to show you a few very simple examples, and then we'll work through some together. That's what your homework and your individual tasks will center on in today's lesson. So after this video, see part 2, and we'll be working through some examples, hopefully to help you out a little All right, we're back, and we're going to do our example problem now. So if we take a look here, this problem can seem a little bit intimidating, but if we break it apart step by step, we'll see that it's just dimensional analysis. Now, before we even begin, a lot of you in your head are being like, Hef, you can just multiply and divide. I know. We're choosing something a little bit simpler than what we'll encounter in chemistry or astronomy to practice using the tool of dimensional analysis. I don't really care how much these pens cost. What I care is that later on, you'll be able to convert astronomical units into light years. You'll be able to convert number of atoms into grams of carbon. And in that case, you won't be able to simply multiply or divide. So it'll be important for us to show our work. And the nice thing is, the structure for those more complex and interesting problems will be the same as the simplistic one. So let's look at it together now. So a class needs 426 pens. Pens are sold in packs of a dozen for $1.75. How many pens will the class need? How much will it cost? So there are multiple parts here. Let's break it apart together. But remember, dimensional analysis really only has 2 steps. So we need to first identify the equality statements. We'll write them down for now, but eventually you'll be good enough that you can skip this step or do it mentally. So first, I need to know that 1 dozen equals, in this case, my things are pens, 12 pens. I also know that 1 dozen, or a pack, equals $1.75. So these are my equality statements. I'll abbreviate it for us here, EQ. So to solve the problem, we're going to bring down the only real measurement in the problem. You're like, there are multiple other numbers here, how do I know what a measurement is? Well, the other numbers, $1.75, that's just a statement about the reality of the situation. The pens cost that much. The only measurement involved is the thing that's unique to this situation. The class needs 426 pens. So I'm going to bring this directly down and say, I need 426 pens for my class. Now, ultimately, I need to know how many packs I want to buy, and I need to know how much that will cost. So the dimension or unit of pens is not my desired unit. One of the units that I would like to convert to is dozen, because that's a synonym for packs. So I'm going to use a conversion factor, just like before, to cancel the unit of pens and get to the desired unit of dozen. If you're not quite sure how fractions work, you're not alone, that's okay, and I'm going to show you a quick trick. The unit you want to get rid of, pens, just put it in the bottom or in opposition to where the unit appears. So in this case, I need to get to a dozen, so I'm going to say 1 dozen over 12 pens. If I look, the unit of pens cancels. Now, most of you know this already, but if you don't feel bad. Some people aren't entirely sure how fractions work in the calculator, or what do the fractions really mean? It's okay if you don't know. I'm going to show you right now. The top of a fraction really just means multiply by this number. The bottom of the fraction really just means divide by this number. Whenever you have a fraction, you're always going to be doing both operations. But sometimes, like in this case, the top of the fraction, the numerical value is 1. If we multiply something by 1, it's just itself. We know that. So we don't really need to do this in the calculator. So when I say, what are we doing here? We're going to take 426 pens divided by 12. My calculator's here. So I just do it step by step, 426 divided by 12. And I find that I need 35.5 packs, or 35.5 dozen. Now, if we wanted to take this one step further and be even more meticulous, we could convert dozen to packs. But we'll see in that case, I know that if I have 1 dozen pens, that's equal to 1 pack. So I think showing your work is very, very important. I think you should always do that. It lets me help you. It lets you find your own mistakes. But we can be realistic too. I didn't bother doing this step mathematically because I think we know what the outcome will be. The number is the same. But I can show you with the tool so you can see the cancellation. If I put this time 1 pack on top, 1 dozen on bottom, the dozen cancels, the dimension or unit that remains is pack. So we can see that it's the same. I need 35.5 packs. Now, an interesting thing to think about before we move forward and calculate the price. We have to do some critical analysis here. The class requires a certain number of pens. Pens are sold in packs of a dozen. When you go to Office Depot, you can't take 35 packs off the shelf, take the 36th pack and tear it in half and say, I would like to buy these 6 pens. That's not going to work. So in actuality, to fulfill our requirement, how many packs would we need? If you said 36, in this case, you're right, because we need to meet the needs of all the students that are there. So we're going to round this number up to 36 packs before we calculate our final cost. So now, I have 36 packs. I know that 1 dozen is the same thing as a pack, and I know that 1 pack costs $1.75. I'm always very careful to put my units where where they need to go. This cancels. In the calculator now, I'm going to take 36 times 175, and I get $63, even. Oops. I boxed my final answer. Now, could you have done that more easily in your head or just using a calculator? Yes, absolutely. Remember, the point of this tool is not about pens or packs or dollars. It's about using it later on to do more complex conversions. And I'll be doing some of those with you in the very near future. As for now, I hope this helps you at least get acquainted with the term dimensional analysis, and I hope you feel a little bit more comfortable when I use that language to say, oh, okay, I know what he means now. So, thank you very much.